So my name is Mark, and I work at LunarG. I've been working on Vulkan since right after it was born, I suppose. LunarG's in Fort Collins, and I guess there's about 15 folks there who work on Vulkan tools, something like that. And then we work really closely with a handful of Google folks. Today we're going to talk about a couple of new fairly new tools that came out in the 1.1 time frame, the Vulkan Assistant Layer and the Layer Factory. Vulkan is a layered API at the bottom, is what's defined by the specification, and then you can insert other layers in between. And part of the API model is that nearly all of the validation is done in some plug-in layers. So you can have them in during development and pull them out later so they don't get in your way. So the assistant layer, I'm going to talk about that first, is basically a best practices layer. And the idea here is that the validation layers focus on what is correct and is explicitly spelled out in the specification. The best practices layer is kind of covering the gray area. It's things that apps might do that are not illegal or prohibited, but that are probably not a good idea and can get you in trouble. And the idea is probably not that you would run it all the time like you would with the validation layers, but you could plug it in every once in a while and see if anything pops up. More likely early in your development rather than later. So right now it's a fairly new layer, and there's a GitHub issue, I think it's 1612, and in here we have all the list of, this is a compiled list of issues and checks and things that people have asked to be in the best practices layer. And so we're going through a little at a time. You can see some of these are checked off, adding these to the layer. Not shown here is a bunch of items from the portability. There was a ecosystem issue that came up about portability, so there's a bunch of warnings to help out with that. All this stuff's in the GitHub issue. And if anyone has any suggestions for more stuff, I will say this a lot during the presentation. Please let us know. We want to make this thing useful and helpful for everyone. Let's see. So we talked about that. So the assistant layer is built using the Layer Factory. Kind of a coincidence. It uses the standard output things that the other validation layer use, debug report and debug utils. So if you have debug callbacks already in your applications, they'll still work with the assistant layer. Another cool thing is that because it's done on the Layer Factory, it's easy to add your own checks. So you could take the built-in set of assistant layer checks, and you could add, if you have internal guidelines or rules or things that you want to enforce in your own organization, it's really easy to tack things onto the end of this layer and customize it for your own use. So what we want to do, I think I've mentioned this before, what we want to do in the near future is add more coverage to the requested list of items. Another interesting thing is right now there are many warnings in the validation layers which are not defined in the spec. And this is probably a leftover from the early days when this is all there was to go by. But over time, the number of warnings called out in the spec has decreased, and it's our goal to get all of those non-specified warnings out of the validation layers and into the assistant layer. So there's a lot of things about transitions and many different kinds of warnings and performance warnings, and all those will move into this layer eventually. Another suggestion we've had from people is that different IHV platforms could have different performance requirements. So it'd be real easy to have plug-in layers or parts of the assistant layer for different hardware platforms that you could plug in and get suggestions or notifications that you're violating best practices on that particular hardware platform. Another thing is be able to switch these things on and off. So this layer is available in the LunarG Vulkan Tools repository on GitHub. real quick, a shameless plug. There's some other cool tools there which can be useful. And as I mentioned before, it's developed using the layer factory, which I'm going to talk about next. So the layer factory is a framework that lets you, so there's a bunch of garbage around creating a layer. There's a lot of overhead and boilerplate. And the idea with the layer factory is that you would be able to remove all that from the process. But if someone is writing a layer, all they want is to do one thing, and there's all the work that's involved with writing a layer gets in the way. We're very close to this because that's all we do is work in the layers, and we don't notice it so much. And this was initially developed to make our life easier, but it turned out it might be useful to other folks. So it takes all of the infrastructure that layers use and kind of abstracts that. And then the idea is that you just create these little interceptor objects which do exactly just what you want. You can focus on the one little piece, getting the work done, and you can kind of ignore the rest. And in fact, when it comes time to output the layer, that's all done automatically for you. So the structure is that you have different layers, and layers can have any number of interceptors. And all an interceptor is basically a structure with the API targets that you want to intercept in your layer and operate on. So for each interceptor, you can have intercept points for each API, and there's an intercept point for each call before you make the call and after the call is made. So free memory, there's a pre-call free memory intercept point and a post-call free memory intercept point. And that makes it easier to check things before and after the different API calls. Let's see. So the reason we wanted to do this is because there's a lot of, like I said, there's a lot of steps you need to do or have to do to get a layer up and going. You don't always have to do all of these. Many people have written layers, but it never has really taken off as I think the community probably thought it would when it started. So the idea is to take all this stuff and abstract it and make it easier for folks to get their work done. So in addition to just doing that, it also provides some helper functions, and this list can be expanded later. But it's got the pre and post call points. There's some much easier output functions. The log message call, if any of you used it, is fairly cumbersome, and we're going through the process of making that easier to use. But there's several easier ways to get output from the helpers in the layer factory. There's some debug helpers, and then there's also a couple of helpers so that if you want to intercept every API call, you can just overload that function, and that happens for you automatically. So to actually create a layer, there's basically just a few steps. You just create a subdirectory, you put a file or two in there, you run cmake, and a layer comes out. It's almost actually that simple. So real quickly, the first step, I'm just going to run through these and do a short demo. The first step is that you create a subdirectory in the layer factory directory in the repo, and that's basically going to be the name of your layer. So if you wanted your layer to be Fred's layer, you would just say create a directory called Fred's layer. This will get picked up by cmake later, and that means the factory will generate the supporting files for you, and then your layer name would be called VK layer, whatever Fred's layer. The second step is that you would create some state tracker files in there, and this can be a header file or a header CPP. There's some examples in there that we'll talk about later. But basically, these just define your object, your interceptor object. And then all you have to do is, which I can't show you right now, is define, override the pre and post call points that you want to intercept. So all you have to do is add them in here. The function signatures are the same as the original API calls, and the name pattern is the same for all of them. You can put your own, variable storage and stuff in your object. And so you create this file. In this case, it's just done in a header file that I'm calling memory allocation stats. And then the next step is there's a standard header file that's used for each of the layers, and this is called interceptorobjects.h. So each of your interceptors has a header file. You just include that in here. So it's you can see the one for the assistant layer has 7 or 8 interceptors, which do, I don't know, they cover 8 or 10 of the assistant layer functions. But that's also fairly straightforward. And then you run cmake. Cmake will go through, pull the files out of the directories, build everything, and it spits out a layer, which you can then run straight away. So in the VLF directory, there are 3 examples. There's the assistant layer, which we've talked about before. The starter layer is the simplest. It's just got a couple of header files. And then the demo layer is a version of the starter layer, which uses a CPP and a header file. The idea from here is that right now the layer factory is in the Vulkan tools repository, and we're actually reworking the structure of a few of our repos, but the idea is that this would come out and be a standalone layer. We also have gotten the idea of automating this even more, which I'll show in the demonstration. This is kind of a proof of concept thing right now, but basically you just run a script and it spits out the function signatures for all the things that you want to intercept and sets up the jump tables. It's easier to show than to explain, I guess. We've had some feature requests from developers. I guess we were kind of implementing this from a layer-centric point of view, and it wasn't as obvious to us how people would want to use these layers in their applications, and they didn't want to mess with the other tools in the repo. They just wanted this one thing that they could take there, pull the files out, and put into their own applications. And so the structure's being reworked to help with that somewhat. Another suggestion was being able to modify parameters and act on return codes, and this is actually in work. And we're always looking for more suggestions and ideas. So real quickly, I wanted to show how this stuff would work. I can switch over. All right. Okay. So bear with me, it's a demonstration. Okay, so let's say we're going to create a layer today called the dev day layer. I'm just going to make a directory. So now we want to create our interceptor. Which we'll do here. Sorry. It's way harder to type in front of a bunch of people. I'll say that. Sorry. See? All right. So real quick, this is just You can see here we have the object definition, and we're going to hook post-call allocate memory, pre-call fee memory, and then we're going to hook qpresent to spit out the results every once in a while. And this is just a super simple layer, and it keeps track of the number of memory allocations you have and how much memory is being used. So we'll save this. And then we need to add our header file. So let's see. That was it. Now, just run CMake real quick. And so then if we switch over here, you can see if we hit reload, we should have the dev day layer pop up here. And we can just build that guy. Should just take a minute. And then, with apologies to Sasha Willems, we'll run one of his demos. It's going to do some stuff here. And you can see we've got this cool thing. The output from the layer is coming here. You can see we have output from a log message call, which is being picked up by his debug callback, and then we have direct output from the layer. And this has the number of allocations doesn't change, but you can see if I resize the window that the memory sizes are rechanging. So that's it. We just made a layer, stuck it in, and used it in 4 minutes. We're hoping that this will be useful to folks besides us. We're even thinking about migrating some of the standard validation layers to use this model. Real quickly, I wanted to show a quick demo of our idea for what this might look like in the future. And here we're in the SDK. And instead of having to create your own interceptors, like using or from the demos or samples, the idea was that you could just run a script and tell it which intercept points you wanted. Let's see if I do this. Yeah. So here, the idea is that you'd run this add interceptor script. You tell it, you tell it which layer you want. We want to call it, this is a completely separate layer. We want to call it the dev day layer. We're going to call the interceptor alloc counts, and we're going to pick up these 3 functions, the same ones we looked at before. So this script actually will generate these files for you. So now we have now we have a dev day layer. We've got the scripts, and you can see that the function signatures are all filled in. So this actually is built on top of the regular VLF stuff that I showed you earlier. So from here you can just run CMake and your layer is built. You don't even have to create the objects or type in the function signatures. It's all done automatically. The other nice thing about this is that it lets you, each layer, it will automatically enable the intercept points just for the functions that you want. The standard VLF, as it currently sits, overloads all the functions, so you have a tiny bit of overhead for getting called in those spots, but this would all be handled automatically. Anyway, this should be, it's in development. It should show up soon in the next couple of SDK releases that that would be coming up. And I think that's all I had. You can switch back to the presentation, please. Can you guys switch the inputs for me in the booth? Thank you. So if you have, well, like I said, all the stuff's in the Vulkan Tools repository. There's a little bit more documentation there and pointers to more resources. And please, if you have ideas to make any, if this looks like something you want or something you'd hate, let us know, and it might save us some work. And you can contact me or my very smart compatriot Mike Schuchart directly. We're happy to answer any questions and take requests. That's all I had for today. Thank you.